I'm going to show you a little bit of the research that we've been doing at IDC before we jump ahead with our panelists. And so I'm just going to quickly step you through some higher level thoughts and trends that we're seeing in the data center market. And one of the things that we look at and continue to track very closely is what we think of as disruption in the data center. And we're actually heading into a very new era, what we like to think of as a new business cycle. So ultimately, for the data center of the future, it's all about driving down the cost of computing per unit of work that gets done. And I think that's been the overarching agenda for a lot of data centers till now. How do I continue to drive cost out of my environment? And that continues, but it continues in a slightly different way from what we've seen today. But what does continue to grow in something of an alarming rate, and that's the number of logical servers installed in the marketplace. So that's the number of physical servers plus all the virtual machines that are out in the marketplace today. So we're already seeing that 50% of all applications are virtualized. So really, really interesting times. I think we've seen from a lot of data centers, they've driven out about as much of the CapEx cost as they can. The average data center in the US today is 12 years old. So think back on that chart that I was just showing you. That was the mainframe Unix era data center. That was the data center that was built for 50, 75 watts per square foot, maybe a kilowatt or two per rack. This future data center that we're thinking of, it's going to be much greater than that. We're seeing hosters that are building newer data centers today at 250 watts per square foot. You start thinking about 10 or 15 kilowatts per rack. So power and cooling is still the #1 problem for the data center today. So I think I'll start with you, Jim, because I know convergence is very near and dear to some of what you've been working on lately at HP. And so maybe you can talk a little bit about what you're seeing around convergence and how you see that playing out in customer environments and what it means for HP specifically.
Sure, my pleasure. So at HP, we have this vision that we refer to as converged infrastructure. If we look at the state of most data centers, and as you can see from Michelle's charts, a lot of these data centers are full of siloed scenarios. What you end up having are data centers that are rigid, data centers that are not very flexible, and unfortunately what that translates into when we talk to most CIOs is that they spend almost 70% of their time just on pure operations and maintenance.
But DY, maybe you can talk a little bit about some of the changes you're seeing on the memory side, on the storage side with regard to technology, and particularly as you start thinking about some of these more converged, higher-end systems that we're seeing coming to market.
10 years ago, it was performance.
Yeah.
Right? Everything was performance. Now, the real requirement is power. Always #1 priority for the development is power. So we've been developing DDR, DDR2, now DDR3. We are working on the future one again. But all those architectures also has been tried to be optimized for this new type of environment, IT environment.
Power has become a concern in the data center where it never really was before. It was a utility delivered to the room and then it was consumed. Today, as a data center engineer or data center manager or even a director, you have to be very cognizant of the capacity and current utilization of power to that room, because you can't order more gear if there is no more power available, and you can't scale to meet a business demand if there is no more power available.
Even though we've seen server counts maybe stabilize, we still continue to see the storage side grow dramatically. Can you talk a little bit about some of the innovation on the Samsung side that will help with that?
But for servers, they used to use very high-end hard disk. It's very for high performance, but relatively less capacity, very fast. But even with those hard disks, if we replace those hard disks with SSD, then not just power consumption reduction, but from performance perspective also, SSD will not replace all the hard disk. But for these critical servers, having SSD, they can earn a lot.
We're going to see all kinds of new things happen in data centers, but I'll just close with this one point, which is the cheapest data center you ever built is the one you never built, right? It's the ability to continue to use the existing infrastructure, and we're going to run into the challenges of, as we go to better and faster machines, the power and thermal footprint for those machines continues to become more and more dense. And so how do we address that over time? Thinking about it far enough ahead to make an effect change is really the challenge we all have.